Good morning and welcome to lesson 11. Okay, so today we're looking at the ASCII table. In our previous taught lesson, the Zoom lesson, we looked at counting systems signed and unsigned, quite interesting that. And in the previous recorded lesson we looked at counting systems, an introduction to that. So the ASCII table today, before we move on to programming languages for the final couple of lessons and then the practice assessment. Right, okay, so all the way down to page 42.
That's a very good point.
Right, okay, so the ASCII table. Right, so what is the ASCII table? Well, the ASCII table is how computers store text. Yeah, so we've previously looked at how computers store numbers using binary. Yeah, so we've looked at predominantly we've looked at how numbers are stored. Well, of course, there's a need to store text as well, and the ASCII table was an initial attempt at how to do this. So, a definition here. ASCII is used as the method to give all computers the same language, allowing people to share documents and files. ASCII is important because the development gave users and developers a common language in which to work. What that means is, basically, when ASCII was defined, people could write a document using English and they could share that document with another person, with another computer. They could open that document and they could see the English text in it. Yeah. Now ASCII what does ASCII mean? Yeah, so here we go. It means the American Standard Code for Information Exchange. Let me put that in a new window. Information Standard Code. And this tells us something about it. It tells us that this was an American standard, and this is important here. It's a 7-bit binary number, so just 128 characters were defined. And the ASCII code, I think it's really quite old. ASCII was developed when? When was it developed? I think it was developed way back in the 1960s or the 1970s. Wikipedia should tell us.
Do you have VLC? Somebody?
Scanning for a date. So around 1963. So 1963. Yeah. So the first version, 1963. So 1963 was a long time ago. Before you were born, before I was born. While computers were very, very big and very, very expensive, and while computers remained the domain of research institutions in the United States and in the United Kingdom. Computers were used by the military, by the US military, and the concept of having to have a method of storing text outside of English characters was not one that was considered way back in the 1960s, in the 1970s. And we'll talk about that in more detail shortly. So, here we've got the denary, the decimal, the binary. This is the symbol. These are the descriptions. And we've got a lot of system codes. The most important ones are still in use today. This is a very important one, this carriage return and this line feed. If you're doing any sort of programming, you'll still need to refer to ASCII value 10 and to ASCII value 13. Yeah, these are still very important codes even today. So we've got a whole lot of system codes, and then here we go. At item 32, we start to get into stuff that we can. Well, we can't see the space, but into some kind of printable characters. So we've got numbers and we've got symbols. A lot of symbols. Then we've got uppercase letters. Then we've got some more symbols, then we've got some lowercase letters, and that's it. Yeah, so 127 characters are defined in the ASCII table. An ASCII table initially was just a 7-bit system, so we will notice that the leftmost bit, the most significant bit, is always 0. That's because ASCII was initially just a 7-bit system. Yes, this 8th bit was never used. Yeah? So going all the way to the bottom, 127. And that is binary 127. So the ASCII table served us well for 30, 40 years. But there are problems with it nowadays, and nowadays we have some new solutions. But first, let's have a look at this. Yeah, so this is your first task. I want you to the answers are there. Let's have a look at the real version. Let's turn off markup. Here we go. Okay. So without the answers. So sort these characters according to their binary value. Okay, so we noticed that capitals come before lowercase. So capital D in this example comes first. Then the lowercase letters come in order. So A, D, I, V. Yeah, so uppercase is first in the table.
So once again, question.
So uppercase D is first, and then we have the lowercase numbers. Yeah, so then lowercase a. So if we sort this word according to their binary value, then this is what we get. Yeah. So your first task today, you've got 5 words or kind of phrases. Can you sort them using the ASCII table? Sort them according to their binary value. Okay. And if you want to pause this video and resume when you've done that, we will continue.
Hey, somebody.
Right. Okay. So I'm going to guess that you've resumed the video and that you've had a chance to do that. So here are the answers.
Have you finished watching the video?
Yeah, so we have capitals before anything else, and then just the lowercase in order, which I think is that. Again, capital first, and then the lowercase in order. Capital first, lowercase in order. This is a little bit more tricky, yeah, so we have the number first, then we have the uppercase, then we have the lowercase. Number, then a symbol, then the uppercase, then the lowercase. Yes, but nothing I think too taxing about any of that. And now, your next task, use the ASCII table to convert these binary codes into words. Okay, so try to find this code. This will tell you a letter or a symbol for each byte. Write down the letter or the symbol that you find, and it should make a word. Okay, so we've got 1, 2, 3. We've got 4 exercises here. So 4 minutes to do that. Again, pause the video and resume when you're ready to check with me.
Of course. Yeah. One of the theorists, one of the politicians, his program was to speed up production, yes, to make it, actually, it was political aim.
Okay, so
to make
the first one,
consume.
I think you all got is computer. The second one, ASCII rocks, yes, so capital, ASCII rocks. The third one here, English for IT. And the fourth one probably took you a little bit longer, but it's not really that difficult. Text encoding is fun. Yeah, text encoding is fun. If we were in a class environment, I would now get you to write some binary for your partner and ask your partner to convert it back. But I don't think we're in the right environment to do that. Right, so we've talked about ASCII and how it was created in the 1960s, 1970s. Well, the new version of this is Unicode. Now let me show you. Let me show you this. This is battleships that I need to print out. So if I go to import a file,
Here it is in the updates. Please download it. Right, so if I go to import this file, now this is the problem. We've got all of these different character sets. Yeah, because okay, ASCII. Where's ASCII? ASCII will be here somewhere. It's probably called. Okay, so Western ASCII. Yeah. So ASCII was one solution proposed by one consortium of people. But of course, as time went on, the Greeks wanted their symbols represented, and so did the Chinese, and so did the Arabs, and so did the Japanese, and so did the Koreans. So we got into this huge mess as the people of these countries started using computers more and more. They wanted to be able to store their text. They weren't interested in storing English. So we've got all of these different character sets. Cyrillic for Russians, and so on and so on. Yeah, and this was quite a problem because if you wanted a computer system that used more than one of these text encoding systems, you were in quite a lot of pain. And as a developer, if you were trying to create a program that supported not just English characters but also Turkish characters and Russian characters and Chinese characters, again you were in a huge world of pain. So the solution was this. The solution was Unicode, and Unicode has various implementations. So we've got UTF 16BE, 16LE, Unicode UTF-7, and UTF-8 is the most commonly used one nowadays. And the deal with Unicode is that Unicode, as we can work out from the name, means one code. Yeah, so we have this one character set that contains every character set that has ever existed. Yeah, so it's a huge long list of characters. At the top bit, you've got the ASCII set, then you've got another character set, then you've got another character set, then you've got another character set. So you've got ASCII, then for example Chinese, then for example Turkish, then for example Russian, and you've got all of these characters in one character set called Unicode. So instead of having to support all of these different character sets, as long as your application can work with Unicode, then you can support any character in the world, any character and any symbol in the world. So about 20 or 30 years ago, there was a big movement towards Unicode, and it still continues today. If you ever venture into programming into C and into C++, you'll come across wide characters, and wide characters just mean Unicode characters, and it's a world of pain, really, dealing with all of these character sets, making the transition from a single character set into wide character Unicode is very fraught. But that's something that we can investigate further. That you can investigate further in faculty, or if you want to do that beforehand, you can investigate as homework. Why is it dangerous? People are buying.
Where have I gone? Okay, so another part of this lesson is not just looking about how text is stored, but how text is compressed, yeah, how we save our text. So look at this phrase. When it's snowing heavily outside, comma space, look outside, it is snowing heavily. Yeah, so this is a simple sentence. We're going to store this in a text file. It's going to take up this much space. Yeah, so one character is going to take up 1 byte. Right, so what I'd like you to do before we go on is have a look at this sentence, answer these questions. How many words, excluding punctuation, how many characters?
Okay, that's one point.
So W is one character, H is one character.
Please,
How many punctuation characters do we have? How many spaces,
including punctuation spaces, how many characters? Given that each character needs 1 byte, how many bytes does it take? And number 7, without losing any words of information, how do you think, that should say, how do you think we can reduce the number of bytes this sentence needs to be stored? Okay, so these questions will take you about 5 or 6 minutes. Pause the video and resume when you're ready to check with me.
Arzu, I really can't understand you. Yeah, I'm sorry, Arzu. I find it really difficult.
Right, okay. So, how many words? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay, what's your opinion about the
There are 12 words.
consumerism?
Excluding, right, excluding punctuation, how many characters? Oof. How do I find that easily? I think I was there. Right, it's a spelling check. Wait, no. Word count. Where's my word count?
Okay, that's
If
a
I
good
do
point,
this,
yeah?
uh-huh.
That our consumerism
Right, okay, so 12 words. So
can cause
characters, no spaces.
environmental problems.
So
yeah?
excluding punctuation. So
That's a
characters
very good
and
word.
spaces. So 59,
Please?
no spaces. But then we need to take out that one, so I think it's 58. I think it's 58 characters. How many punctuation characters are there? Two characters. How many
What do you mean by
spaces?
social justice? How is
1,
it connected
2,
to
3, 4,
overconsumption?
5, 6, 7, 8, 9, 10, 11. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 11 spaces, including
No,
punctuation.
let's talk about consumption in terms of goods. Yeah? Clothes, technology,
Okay, so
food,
71.
something that we buy all the time. Yeah?
Where's my
Let's not talk about water consumption.
71?
It's a little
Given
bit
that each character needs 1 byte, how many bytes are
different.
needed?
And what
Are
about
needed?
the next
Well,
one?
that's easy. 71 bytes. Without losing any words, how can we reduce the number of bytes? We can compress the data. Yeah, we can compress the data. But how? How do we compress the data? Well, we can see that several words are repeated more than once. Yes, so here, it is snowing. It is snowing. It is snowing heavily. It is snowing heavily. Outside, outside. We've got lots of spaces, 11 spaces. So if we were smart, we wouldn't store it is snowing heavily 2 times. We would just store it once, and we would store an arrow, a pointer, to the location, telling us where the second instance is. So I've started this for you. So when starts in position 1, so this is position 1. It starts in position 6, yeah, so 1, 2, 3, 4, 5, 6, yeah, so this is position 6, and so on and so on. So if you can go through this table and complete the starting positions, also for spaces, for commas and for full stops, then we can talk about this more. So pause the video, do that, and then we'll be ready to continue.
So it's number 4, yeah? So what is marketing, first of all? Selling, okay. And can you give me
Right, okay.
examples of very successful marketing?
So we've got these starting positions here. We've got lots of spaces,
Okay.
and we can see that we've got these words that repeat twice. So actually,
Apple, okay, fantastic.
So actually-
that
we have 36 bytes here. If we add up the length of all of these, and then here we've got 24 different locations, different starting positions. So if we're smart and we just store each word or each character, if we just store this information once, and then we store a list of starting positions, we don't need 71 bytes, we just need 36 plus 24, 30, 40, 50, 60 bytes. Yeah. So if we just store this information once and then we store the location of where these words start, we just need 60 bytes, which is a saving of 10 bytes. Now 10 bytes is nothing really. I mean, you know, it was a small amount of space 70 years ago, and it's an even smaller amount of space nowadays. But still, when we're dealing with large amounts of data like we do in databases, then being able to save small amounts of data very, very often does lead to significant gains. Right, okay, so I'd like you to do the same. We've got another phrase here: ask not what your country can do for you, but what you can do for your country. What's the starting position? How many total bytes to store the word information, and how many total bytes do we need to store the starting positions? Okay, so you can pause the video and do that, and then we will check together.
Constantly sending me adverts. They're constantly sending me some special offers. So their marketing is very strong. And if I don't open their emails, I don't want to buy anything. Yeah? But if I open it and I start looking,
Right, guys, okay. Well, welcome back.
But I don't need it.
I hope you've had a chance to look at this phrase and to
Yeah. So that is kind of marketing. It's how they're making us to buy it.
That doesn't help.
Yeah, we don't want it, but they're making us.
Right, well, I don't have the starting positions here for this phrase. I will add them to the latest version of the answers document, so look out for that so that you can check your answers. And that concludes lesson 11. Yeah, so we've looked at how text is stored, how text is stored using the ASCII table. We've talked briefly about the evolution of the ASCII table, what's come after it. Again, if you do want to explore Unicode, do explore Unicode, because it's a very important character set for storing all sorts of characters from all sorts of languages. Yeah, it's becoming the de facto character set, whereas ASCII was the only show in town 50, 60 years ago. Nowadays, Unicode is becoming the only show in town. So if you do want to spend time investigating Unicode and UTF, especially UTF-8, then that will be time well spent. Compression of data is also important. Like I say, these are small gains, but when you add up these small gains, cumulatively, they do result in some big gains. Yeah, and it's important to even just understand the principle that if we're smart and we just store each word once, we can just store a pointer to the word. We don't need to store the word 2 or 3 times. Yes, and when you compress your data using things like WinZip, Microsoft Word does it automatically. It will compress your data for you. It will reduce the size of your file. A useful exercise as homework might be just to take a very, very simple but very, very big text document, save it as a text document, copy the same information into a Word document, save it as a Word document, and you should see that the Word document is significantly smaller. Yeah, so if you want to try that exercise at home, then please do. Let me repeat that. Take a very, very simple document, a piece of text, maybe from a book or something, several hundred kilobytes in size. Save it as a text document,
Text documents won't be compressed. They're stored as text. Then copy paste into a Word document. Save it as a docx document. Word will do some things behind the scenes to compress that data. And then in your File Explorer, if you compare the two files side by side, the size of the text document should be much bigger than the size of the Word document. And if you then zip that Word document, it should get even smaller. Yeah, so that's something that you can try at home. Right. Well, our next taught lesson is Programming Languages 1, which is very, very nice, very interesting that. And then our next, our final asynchronous lesson is Programming Languages 2, which I'm just finishing the materials for at the moment. Okay, guys, very good. Bye bye.